Welcome to Everything is Changing. In each episode, we focus on circular economy, ecosystem restoration, energy transformation, sustainable mobility, and water resources. I am Ahmetcan Uzlaşık. Perspective is everything, and everything is changing. In this episode of Everything is Changing, we are joined by Pascal Egli, a mountain athlete and glaciologist contributing to the EU-funded CryoSCOPE Project, which studies the rapid transformations of the cryosphere. Pascal explains what the cryosphere is, why its shrinking spells trouble far beyond icy landscapes, and how cutting-edge science is helping us better understand permafrost thaw, glacier lake floats, and cryosphere climate feedback loops. From skiing in Norway to fieldwork in Himalayas, he shares first-hand stories of climate change in motion and why what happens in the Alps and Svalbard affects us all. Welcome, Pascal. It's great to have you here.
Thank you.
It's a very technical topic, so I think it is better to start with the basics, in my opinion. Could you explain to our listeners what the cryosphere is and why it is such a crucial component of our planet's climate system?
Yeah, the cryosphere, that's a very big term because it encompasses snow, glaciers, and permafrost. So all sorts of water in solid form, basically, on planet Earth. And yeah, if you think about planet Earth, cryosphere is basically everywhere. We have the big ice sheets, Greenland and Antarctica. Then we have the major mountain ranges that are glaciated, like Himalayas and Andes and the Alps, that count in total globally more than 200,000 glaciers. But then, not to forget, the whole, especially northern hemisphere, but also southern, has lots of seasonal snow every winter. For example, Canada, US, Russia, and China especially, but also northern Europe, but also part of the southern hemisphere in South America, for example. And so it's essential because water that we're using is stored in the cryosphere. So it's a temporary storage, and lots of people depend upon that. For example, it's estimated that globally about 1.5 billion people depend on glacier meltwater for seasonal water supply. And it's not only for drinking, but it's also for industry and for hydropower, for agriculture, of course, which is a huge number. And this is now, of course, severely affected by climate change. It's changing very rapidly all over the globe, the presence of the cryosphere.
As you said, the cryosphere is shrinking right now. And you mentioned that it's a bit, but I want to ask, what are the broader implications of this loss? I know that you're also personally interested in, for example, winter sports, you're a mountain athlete and everything. How does it affect you? And in broader terms, how will that affect us in the future?
Yeah, that's very nice that you asked that, because it's true that I experience it almost daily in winter. I train a lot on skis and ski mountaineering, but also skating, like cross-country skiing. And I also go ice climbing and so on. I go hike on glaciers and run on glaciers. So yeah, currently I see the changes a lot because I live in Norway, in middle Norway. And here there's much more rain events now in winter. So sometimes the snow melts or the snow gets like very wet, and so the conditions are not the same anymore. So many actually professional cross-country skiers live here and they train every day on snow. And if we have more rain events, their training conditions are changing drastically, deteriorating. But of course, I also see it when I go on ski tours and you have to suddenly carry skis 500 meters up in spring because there's no more snow in the lower part. And then, of course, when I go on mountaineering on glaciers, because actually the glaciers are becoming more dangerous in general due to that, because we have more rockfall. The rocks are becoming loose, they're not attached by ice anymore. Some crevices are less covered by snow, so the holes in the glacier, the crevices, we cannot just walk over them peacefully anymore because the snow cover is thinner. So there's lots of effect, and yeah, I do experience it a lot. By the way, what I forgot to mention before is part of the cryosphere is also sea ice, and sea ice plays a big role in global climate regulation as well.
Ice has a big role on helping in regulating the Earth's temperature, right? So the presence and absence of ice has some really important effects on climate balance, right?
Yes, both ice and snow. And one of the most important effects is probably reflectivity. It's called albedo, and it's the ability of a surface to reflect sunlight back into space. So if you have shortwave radiation, solar radiation incoming, if the surface is very bright, like snow or ice, around 80 to 90% of that energy is reflected back instead of warming up the surface. Whereas if the snow is gone, the snow is melted, or the glacier is melted, the surface is much darker. It can be only around 10 to 20% that is reflected, or even less. So it's a huge change in energy balance, especially in the northern hemisphere, with a decrease in winter or spring snow cover, but also decrease in the glacier cover. So yeah, that changes. That is a direct feedback on the climate, both globally and sometimes also locally.
There's another term that I'm having a hard time pronouncing it, which is called permafrost thawing,
Yes.
which is something that I also didn't know it before. Could you walk us through why this is alarming, especially in terms of maybe methane release and feedback loops?
Yes, permafrost thawing is a big thing, as you say, methane release. So because these certain soils especially in Siberia, in general in the Arctic, they have been frozen for thousands of years. They contain a big amount of methane, and if they thaw now, with a warming mean annual temperature, they release this methane is not trapped anymore, and they really release this into the atmosphere. And methane is basically it's a 21 times stronger climate gas, greenhouse gas than CO2. So the effect is extremely strong. It's a bit more short-lived. It like decomposes faster in the atmosphere than CO2, but this is a huge feedback. By the way, talking of permafrost, there was a huge event yesterday. Maybe you've seen it in the news. Maybe you didn't, but in the Swiss Alps, there was a huge glacier collapse yesterday that destroyed, buried an entire village. And basically, this hasn't happened in the past 200 years. So it hasn't happened in modern civilization at all in the Alps. This glacier collapsed. Well, it's still being investigated, but most likely because there was an unstable rock slope at almost 4,000 meters above sea level. And this rock slope, it was released because the permafrost in the rock was melting. So the rock was not stable anymore. It was like glued together by the frozen by the ice. And the rock was released. It fell onto the glacier. The glacier was loaded with so much weight, and it eventually got destabilized. And the whole glacier, with all of the rock on top, it collapsed in a huge avalanche down into the valley, 2,000 vertical meters down, to bury an entire village. So that's now ongoing, and it's really quite catastrophe. But luckily, of course, there were monitoring systems in place, so people were evacuated beforehand.
First of all, that's horrible. But this is, I think, a very important dimension of this issue, because when we talk about these terms, it's always very scientific, and we often cannot associate with them with real life effects. So maybe I should ask here, in terms of real world impacts, what other examples can you give when we are talking about rapid melting in these mountains and how it is affecting the regions, local communities, maybe local economies, and the ecosystem itself?
Yeah, I see it especially in the Alps, how it's influencing, well, both the safety of certain villages, but also, tourism and mountaineering, because there are now much more frequent rock falls in areas where there weren't so many rock falls before, due to this warming trend. And that's seen in scientific publications, but I also know it from reports from mountain guides. And so I would say that's mostly threatening certain villages. But of course, it's changing the whole geomorphology of the mountain environment. And it's changing actually how people go to the mountains. Like there's some mountains or some climbs, some rock faces you cannot even go to anymore because they're so unstable and so dangerous. Some entire climbing routes have been lost due to major rock falls. But it has also bigger implications on construction at high altitude. It's not stable anymore, and so on.
Well, now I want to zoom into your project. What exactly is CryoSCOPE and what motivated its creation?
CryoSCOPE is a big project, so it's very difficult for me to have the overview. I'm one of the contributors. So it's a EU project funded by EU Horizon, and we are 19 institutions in Europe and in India, so very diverse. So the idea is to investigate the interactions between cryosphere, hydrosphere, and atmosphere, contribute with new methods, but also new knowledge about processes to improve how we can exploit knowledge about these processes for actually applications such as hydropower, so prediction of water availability, snow availability, winter trafficability, and so on. So it does have an application background, and also, by the way, natural hazards, glacial lake outburst floods. And so it has several components. It has people working on the release of methane, as you talked, in the Arctic from permafrost. There's people working on glacier hazards like me with glacial lake outburst flood, how they are changing in the future, also both in Norway and in the Himalayas. And then lots of people working with the energy balance and so snow hydrology and sublimation. So how much of the snow and ice we actually lose directly to the atmosphere and doesn't even end up in the river. Yeah, so it's quite a multi-dimensional project and quite complex because there's both industrial and academic partners.
And I read that it covers many regions right now, like Svalbard, if I'm pronouncing it right, the Alps, and the Himalayas. Why were these particular areas selected and what makes them scientifically significant?
Yeah, it covers exactly Svalbard, but also Scandinavia and the Alps and Himalayas, you're correct. And Iceland, by the way. Yeah, why were they chosen? I would say it's a mix of some existing measurements and monitoring going on in this area by researchers and our like the researchers' interest in this area, but also the relevance. So, for example, Svalbard is like a natural laboratory representing a big part of the Arctic. It's a very convenient place to work, to study processes. The Alps are extremely relevant for, yeah, because lots of people live there. And then obviously the Himalayas, which have a downstream impact on nearly 1 billion people. So it is a mix of existing monitoring and measurement efforts and the relevance, I guess, of the study.
Do you think the current models struggle to, how to put it, accurately predict cryospheric changes? What are the limitations that we have with these models today?
That's a big question. It's I mean, I myself am not pure blood modeler, but I would say we can already predict quite a lot of things, but there's a lot of uncertainty in future climate predictions. There is uncertainty in knowledge about processes, and there is uncertainty due to a lack of measurements. We have actually, like, the number of monitored glaciers worldwide is very small. So whenever we try to model or represent glacier evolution, it's based on a very small amount of samples. And of course, we want to change that. I would say we can represent the general glacier evolution quite well, but for example, processes like glacial lake outburst floods, they are quite poorly understood from a process point of view.
How are you combining, as far as I read in CryoSCOPE's info sheet in your website, you are combining Earth observation data, AI, and physics-based modeling to improve your predictions. But how does CryoSCOPE actually does that?
Yeah, that's also a big question. So it depends on which area it's applied for. But for example, I know that some groups they try to use machine learning techniques with satellite data to estimate seasonal drought risk from that, which is, yeah, it's really entirely possible on freely available satellite data. Then there's, for example, a private company using satellite data to quite accurately produce snow depth maps over the entire Alps at a relatively high resolution. What we do in glacier modeling, we use present and future weather and climate data. From that, we run a numerical model simulating the present and future evolution of the glacier under a given climate scenario. So that's a numerical modeling of physical processes. But then we have a different type of model that imitates these physical processes by emulating processes with machine learning. So it's kind of statistically approximating what the numerical model, the physically based model, does and arriving almost at the same result. And that's the goal, because that model, the machine learning based model, can be more efficient at doing that. And so if you want to, for example, model lots of different scenarios or a huge or represent this over a big geographic area, it can be much faster. You need less computational power. So in our case, we're combining that. For example, we are evolving glacial geometry for future scenarios, and then we try to model mechanistically, so we physically based model how the outburst flood at a certain stage of the glacier behaves. And then we even try to represent this outburst flood process with an emulator, so with a machine learning based model to kind of make it more efficient.
Well, as far as I know, CryoSCOPE has started like 3 months ago, so it's a new project. It will go on for 4 years. Looking ahead, in your opinion, what would be success look like for CryoSCOPE?
Yeah, that's a very good question. I would say success is already if we manage to send in all the deliverables on time. I think that's the main goal. We have deliverables for different topics, for different tasks, and they have clear submission dates. So that's usually a document showing results and data that we collected and that we obtained, and then also scientific publications. That's the success. Anything that's on top of that is a bonus, like if we manage to find out something more or have an additional publication. Or part of our deliverables, by the way, is also communication, so what we're doing right now. So that's also deliverable. Yeah, that's how we would define success, I guess. And that everyone is fine and no big accident happened during fieldwork in the mountains. That's also a goal.
To summarize, imagine a person from probably, I don't know, living in Tunisia or Egypt is going to listen to this podcast. And he or she might say, okay, this sounds like a huge problem, but it's covering Scandinavian countries or more northern countries. Why should I care? So it's our world in the end, of course. What will be the implications of the shrinking of Cryosphere for everyone living in this world?
That is a very nice question. I mean, one big impact on the long term, obviously, is sea level rise. If we have melt of major ice sheets, we will have. That's a clear impact for any person in tropical areas or near the coast. But there are others. As we said, there are big feedback mechanisms. So the permafrost thaw that releases methane that heats up the atmosphere more. And then there is the change in albedo, in reflectivity, so where we have also an added warning due to the disappearance of snow and ice. So all of this makes climate change worse. This climate change for people, especially in warm countries, it's even worse, because you're going to have more violent storms, because the warmer atmosphere is more dynamic. And the warmer atmosphere contains more water. So more water means more intense precipitation events. So you can have extreme rain events that are quite dangerous as well. And finally, the heat. Like, I have been to Pakistan last summer, and there were these heat waves where people could barely just survive anymore, because it's more than 50 degrees and their air conditioning didn't work. Like, for example, you had an electricity shortage. Can also be due to the heat, by the way. Above 50 degrees, no human can live. So it's simply a limit to human existence in that heat. And that's actually very closely linked also to the disappearance of the cryosphere.
Thank you very much, Pascal. That was an amazing conversation. Thank you for all your insight.
Yeah, thank you, Ahmed Tigan. Thank you.
That was Pascal Egli from the CryoSCOPE Project, helping us unpack the vital but often overlooked role of cryosphere in our global climate system. If you found this conversation eye-opening, Follow Everything is Changing for more interviews on science, society, and survival in a warming world. Do not forget that perspective is everything, and everything is changing. See you.